This is what we discussed yesterday. Complete laws of expressions. Uh, exponents. Complete laws of exponents. When x raised to the power of 0 is 1, x raised to the power of m, x raised to the power of n is x raised to the power of m plus n. This is a product rule, and this is the quotient rule. If it is x power m by x power n, then it is x power m minus n. We are going to use all these rules today in examples as well as in exercise. So xy whole raised to the power of m equals to x raised to the power of m, y raised to the power of m. M just splitted, m exponent is given to both for x and y, which is inside the bracket. Same for this. M is for x raised to the power of m, y raised to the power of m. Just m splitted for x as well as y. If something is in this way, negative x raised to the power of negative m, that is going to be 1 by x raised to the power m. Why like that, I already explained in yesterday's class. Okay, I think you people remembered solving these things, mainly about odd exponents. If the exponent is odd, we end up negative result. If exponent is positive, even 2, 4, something like that, you end up with positive result. For the negative number, odd exponent, negative result. For the negative number, even exponent, positive result. Remember that part. So we are done with example 1 yesterday, and this is example 2. This one also we are done. Now we are into this concept. So here, roots are opposite of exponents. You already know. What does that mean? You see here, root 25, I wrote it 5 square, because 5 square is nothing but what? 5 square is nothing but 5 into 5, which is 25 only. So instead of 25, I wrote 5 square. Why I wrote like that? So that I can reduce, I can remove this root. What is the meaning of root? Let's say x root x. What is the meaning of that? X raised to the power of 1 by 2. What is the meaning of cubed root of x? X raised to the power of 1 by 3. It is the fractional exponent. This root or this one, both are same. If it is 4 root x, then it's going to be x power 1 by 4. If it is nth root of x, then it is x power 1 by n. This root and 1 by, this reciprocal thing, the fractional part, both are same. So what I'm trying to do is, why I wrote this 25 in terms of 5 square? Because we already have a root. So root is nothing but what? Whole raised to the power of 1 by 2. Now apply the rule, whatever you learned, like it is, the power rule we are applying. Here it 2 and 1 by 2 in multiplication. Multiply them. 2 into 1 by 2, 2 by 2. So just cross out this 2 and 2, you end up with 5. So that is the story of root 25, which is 5. Now if it is cubed root of 6 raised to the power of 3. So 6 power 3 as it is. What is the root 3 meaning? Whole power 1 by 3. That's what I wrote. And I applied power rule. Hope you remember these rules. I'm applying this rule. Where is this? This rule. M into n. So m n. X raised to the power of m, whole raised to the power of n. Then it is x raised to the power of mn. Mn must be multiplied. 3 square and 2. 3 raised to the power of 2, whole power 4. So 2 into 4, 8. We multiplied both. So here also same thing. Once we turn this root into 1 by 3, we are multiplying 3 into 1 by 3. 3 into 1 by 3 is 3 by 3. That's what we wrote it here. 3 by 3 is 1. So 6 raised to the power of 1, it is 6. So that's it. If you do for the next one, it is, you get same thing. How we got this b? B power 4 as it is. What is the meaning of root 4? Whole raised to the power of 1 by 4. Cross out this 4 and 4, you end up with b. So now let's discuss about this x power 2 root 3. What is the meaning of this x power 2 by 3? Sorry, not 2 root 3, 2 by 3. So let's split it. X square as it is, let's split it like 1 by 3. I just separated the numerator and denominator this way. If you multiply, it's still same. So what is the meaning of this 1 by 3 again? It is cubed root of x square. That's what it is. Or else you, if you do this way, you can do this way also. Let me show you. 2x raised to the power of 2 by 3, you can write like this: x power 1 by 3 whole raised to the power of 2. Here just reverse, like here we took 2 and 1 by 3, here we took 1 by 3 inside, 2 outside, still same. If you multiply this 2, you get 2 by 3. If you multiply this 2, you get 2 by 3 only. So now that is going to be x whole power 1 by 3 is nothing but cubed root of x whole square. So the same term can be written as x raised to the power of 2 by 3 can be written as cubed root of x square. X raised to the power of 2 by 3 can also be written as cubed root of x whole square. Both are same, but mostly we use first one, not second one that frequently. Now, just a second. I think you can able to see the question, example 3. Just choose and I'll just send you a poll. 1 second. Okay. A, B, C, D. Try this question. Try this question. Okay, I just sended a poll. Go and click the poll and then click on one option. What answer you are choosing? Just solve it and tell me what is your answer. Just through a poll. I sent it a poll. You can do that. I'll give you 1 minute. Try solving this question just like the way I did previous one. Still didn't choose to poll. Nobody chose poll. I'm waiting. What will be the option? Okay. Okay, I got, yeah, I got the answers. Yes. Just a second. Yeah, I got your results. You people selected C and it's right. It's so easy. Let me solve it. So first what we do, we just have to convert this. So option C is right. Y fourth root of x raised to the power of 5. X raised to the power of 5 same whole power 1 by 4. Yes, it's going to be x raised to the power of 5 by 4. Yes, you are right. Okay, let me tell you this one. So the expression 25 whole raised to the power of 2x root 5 whole raised to the power of x is equivalent equals to 5 raised to the power of kx, where k is a constant. What is the value of k? So we have to find k value. So how can we find that? So what I do is, here you need to notice one thing: 25 5 5. We have to try to make LHS and RHS equal so that we can able to get the value of k. Why like that? There is only one thing we can able to get the value of k. So we learned one thing in yesterday's class, that when bases are equal, equate powers. So this is what we have to do. Why? The thing which is we are dealing with power, there are going to be, we are going to deal more questions based on this. Whenever the question is about power, definitely we are going to use this one, this rule: when bases are equal, equate powers. Remember, just it's a fixed thing. More number of questions going to come this way. They are going to ask you about the power k or power something. So how do we solve? We try to equate this whole thing, bases equal, and then we equate powers. Let me solve it. You need to get the immediate idea whenever they ask you to solve or find the value of power of, I mean, sorry, base of something or the exponent. You need to get this idea definitely. Only this way you can able to solve it. So now what I'm going to do is, this 25 is there. I am going to write it as 5 square. Why? Because I want to make it equal to 5 so that I can use the rules. Why I'm trying to do that? You see, every rule here, x, then only rule is applied. Let's say x, y is there, x power y power n. You can't apply the rule. Here, x bases must be same. Then only this rule is applied. You see, all the bases have same thing. Then only you can able to apply the rule. Bases must be same. So that's why what I'm trying to do is, after watching the things, you get idea immediately. What's that 5 square? Why? So that you can make this one also something like that. Like you see the root 5, we can turn this root 5 as 5 raised to the power of 1 by 2. And remaining part, you just keep it same. Whole power 2x, whole power x, same as it is. That equals to 5 raised to the power of kx. Now just apply the power rule. It's going to be 5 raised to the power of 4x divided by 5 raised to the power of x by 2. That equals to 5 raised to the power of kx. So now we are going to apply quotient rule, this one. X raised to the power of m, x raised to the power of n, divided by x raised to the power of n, then x raised to the power of m minus n. So it's going to be 5 raised to the power of 4x, minus x by 2. This is what we are going to get. Bases are same, so I just did it this way. So this is going to be 5 raised to the power of kx. So this is 5. 4x is 8x minus x by 2, which is 7x by 2. 5 raised to the power of 7x by 2, that equals to 5 raised to the power of x. So what I said in the beginning, when bases are equal, equate powers. So immediately they asked us to find value of k. K is in the place of exponent. For that, definitely you have to use this. If you are using this, you have to make bases equal. To make bases equal, that kind of idea must generate in your brain. So I turned this 25s and 5s to make it 5 match with the RHS. Now bases are equal. These are bases. Bases are equal, equate powers. So which is 7 by 2 equals to 7 by 2x, kx, xx gone. I mean, sorry, cross out, that's k value is 7 by 2. Just if you understood, just say yes. If it's completely clear, just say yes. Yes, thank you. Okay. Hold on for a second. Yeah. Question example 5. So what they're saying here, if the square of a is equals to cube of b, where a value greater than or equal to 0, b value greater than or equal to 0, for what value of x, root a raised to the power of x equal to b. So they're asking us to find the value of x. For what value of x this will be equals to this. So what I'm going to do is, let me keep this. Let's take the given information and find the value of x. At the end, we have to find the value of x. So we have this information, a square equals to b raised to the power of x. And we also have b is nothing but a raised to the power of x. I mean root a raised to the power of x. So what we do, a equals to this whole thing and we need to find the value of x. What I'll do is I'll take this value and I'll place in the place of this, but I don't think that's going to be helpful because cube is there, root is there. So let's take a equals to b raised to the power of 3 and here 2 is there. I just want to get the value of a only. I'm trying to get the value of a. So I want to remove this square. I want to remove this square. How can I remove this square? I am going to do square root on both sides. Why I did this one? So that I can able to remove the square thing. I will get the value of a. I'm just writing square root on both sides. So that root and square off. Why? I already taught you root a square that equals to a square whole raised to the power of 1 by 2. This root is nothing but whole raised to the power of 1 by 2. 2 out, it's still a. So that's how we can directly cross out this root and square. So we got a equals to cube the root of b and I'm writing this as 3 by 2. A equals to b raised to the power of 3 by 2. Why? Root is nothing but 1 by 2. Root is nothing but 1 by 2. 3 into 1 by 2, 3 by 2. So you need to do things a bit directly. Every time we can't go all steps. Now, root a power x. What we got? A is nothing but b raised to the power of 3 by 2 x root that equals to b. So now what I'm trying to do, we are dealing with something which is in exponent. X is the exponent thing. So same formula, whenever you see that bases are equal, equate powers. Now I'm trying to make this bases equal. How I'm going to make this bases equal? So here root is there, but it must be only b. We have to remove this root, then b bases will be matching. So I'm trying to match the bases. To match that, what I do now is I want to remove this root. How can I remove? Square root, squaring on both sides. So if I do squaring on both sides, so this part, for this part, I'm just going to square it. Square, whole square on both sides. So what happens? The square and root of, so we ended up with b raised to the power of 3 by 2x that equals to b raised to the power of 2. Now bases are equal. The same thing we did just before. We tried solving question k. Where is k? K is in the exponent. Whenever you are trying to solve the value of exponent, you must have to use this one only when bases are equal, equate powers. So I did some manipulation and I made this bases equal. Bases equal when bases, just a second, when bases are equal, equate powers. So that's what I'm going to do now. So it's when bases are equal, equate powers. So what I'm going to get now? Bases equal 3 by 2x that equals to 2. I equated powers. So we need the value of x. So x equals to 2 multiplied by transpose this. It get reciprocated. 2 by 3. It is 3 by 2. It becomes 2 by 3. If you don't know that, what you do? We want to remove this. To remove that, what do we do? 2 by 3 on both sides. 2 by 3 on both sides. So when you do 2 by 3 on both sides, why do we do that 2 by 3 on both sides? That is the way you can eliminate this 3 by 2. Then you will get the value of x. Final intention is to find the value of x. So this is, let me erase this 3 by 2 thing. So 3 by 2x, that equals to 2. And we are multiplying 2 by 3 on both sides. The reciprocal of this thing, it is 3 by 2. We are multiplying 2 by 3 on both sides. When we multiply 2 by 3 on both sides, it will give us 2 into 2, 4 by 3. This is what we are going to get. So most of the time, don't try to do this 2 by 3 on both sides and all. Whenever you transpose, just the reverse of this will come to this side. 3 by 2 will become 2 by 3. Remember that way. So 4 by 3 is the answer for this. Okay, is that clear? Just type 1, ONE1 if it is fine. Okay, I got one message. Fine. Let me know if you have any doubt. I can continue from there. Okay, no doubt. Fine. Thank you. So I'll just continue from the next one. So here, it's about radicals. How to simplify the square root thing, the radical part. This is called radical. The square root, radical, rad, all are same. Square root, radical, or we call it as rad, RAD, rad. All of them are same. These all are same. We are going to simplify things under square root. How to simplify things under square root? Here 48 is there. So let me tell you, we are going to use one method, which is factorization. Short division method we are going to use. SDM, let me write it. Short division method. I don't know whether you know or not. I'll just quickly remind you. Short division method to do this factorization. So what we do, how do we simplify things under root? So write down 48. What is the first rule? In short division method, you need to start with least prime number. And you need to divide it. Division method. This is a division method. Start with least prime number and divide. Start with least prime number. So the least prime number is 2. So 2 2's 4, 2 4's 8. 2 24's 48. I did division. Just division. 2 48. 2 24's 48 we get. Just division, nothing else. And write down the quotient below. The quotient you have to write below. And then continue with the same prime number. Continue with same prime number till it break. Like 24 is an even number, it's going to work in the 2. So continue with that. Same prime number till it doesn't work. So now 224, 2 12's 24. Again continue, 2 6, 2 3's. Now if you go with the 2, it's not going to work. In 2, 3 doesn't exist. So you need to move for the next least prime number. What is the next least prime number? 3. So 3 1's 3. Next least doesn't work. Then go for next least prime number. This is how we do. So what all things we got? 2 2, 4 2's 1 3. 4 2's 1 3. That's how we wrote this. 1 2 3 4 and 1 3. You can see here 1 2 3 4 and 1 3. So now what we do, from here root of just separate it, like consider these two roots, these two 2's, these two 2's. I'm just showing you this one. Root of this 2 2 is nothing but we can write 2 square, because 2 2's are there, 2 square we can write. Square root of, so that's how this 1 2 came out. In the same way, this from out of 2 2's 1 2 came out. Here only 1 3 is there, you can't bring it out. If there is 2 3's, then it will become root 3 square, square root of, then 1 3 comes out. But there is no 2 3's under the root, so it is under root only. So 2 2 root 3, 2 2's 4 root 3. Same story for this 72 as well. If you just do the short division method, 2 36 72, 2 18s 36, 2 9s 18, and 2 doesn't work. Go for the next least prime number, which is 3, 3 threes, and 3 ones. So 3 twos, 2 threes. So how many twos are there? 1, 2, 3. How many threes? 2 threes. 2 twos, 1 3, 1 2 out. 2 threes, 1 3 out. 2 will be inside. So 2 3 6 root 2. So here this is square root. That's why out of 2 roots, 1 2 is getting out. If you still didn't understood, I'll just write one more step here from here. Root 2 square. This thing I wrote it as root 2 square, root 3 square, and root 2. So this is square is nothing but whole power. Root is nothing but whole power 1 by 2. 2 square whole power 1 by 2. 2 out. So you end up with only 2. So that 2 is coming here. In the same way, 3 comes here. Root 2 here. And you multiply 2 and 3, you get 6 root 2. Now, here it is square root, fine. Now, what about 16? What is the 16? If you do the short division method, 16, 2 8s, 2 4s, 2 2s, 2 1s. So what you got? 4 2s. 1, 2, 3, 4. Here cubed root, be careful. So cubed root, you have to take 3 roots. You can't take for cubed root, I'll take 2 square and I'll cross this. No, you can't cross it. How can you cross it? Because this is different. 2 power 2 and 1 by 3. This will be 2 power 2 by 3 you will get. In the previous case, root 2 whole square, that's going to be 2 power 2 whole power 1 by 2. That is 2 power 2 by 2. Cross out will happen. Here 3 is there, so you can't cross out. And whenever 3 is there, you have to go for 3 twos. Then what do you get? 3 twos means it's going to be 2 power root, 2 power 3, and 1 2. And then split it. 2 power cubed root of 2 power 3 and cubed root of 2. This part will cross out. Let me rewrite so that you'll understand better. So from this step, what happens? This thing I separating cubed root and cubed root of 2. 2 power 3 cubed root means what? Whole power 1 by 3. This out. That's cubed root of 2. So 2 cubed root of 2. So 2 cubed root of 2. That's what we ended up with. So this is how we do solve or simplify square roots. Just a second. Let's go for the next question. Okay. So try this question. So which of the following is equivalent to this? So we have to pick one option. After solving, this will be equal to one among them. So x square whole power 3 by 4 is there. So x multiply 2 into 3, 6 by 4. 6 by 4 means x power 2 3s, 2 2s, 3 by 2. So x power 3 by 2. Do we have x power 3 by 2 in any of the option? What is the meaning of this? Option A? A option is what? X root x, that is x power 1 by 2. So no. What is option B? X power, no, only x and root x. X power 1, x power 1 by 2. Root x means 1 by 2. That equals to x power 1 plus 1 by 2. Apply the product rule. Bases are equal, so you can add up. That's going to be x power 2 plus 1 by 2. That equals to x power 3 by 2. This is matching, which is option B is right. So you check with this option D. That means x power 1 by 4. That's not matching with this. You can check this. You get x power 2 by 3. Here we want 3 by 2. So option C is also incorrect. So only B is the answer. So this is the entire concept and whole examples covered about exponents and radicals. We just left with some exercise and some 5 exercises, minimal number of questions. We just have to do them. Then we are done with this. We are done with this complete. What do you say that? Chapter 1 in SAT. Just say exercise 1. If you want me to start with exercise 1, just text exercise 1. And let me know if you have any doubt. Yeah, thank you. I can see clearly. So let's start with exercise 1. Before starting exercise 1, okay, fine. I think you remembered about if the power is odd, then output is negative. And if the power is even, output is positive. So here, negative 1 whole raised to the power of 10. Negative number whole raised to the power of even. If it is even, you will get positive 1. 1 multiplied to itself 10 times, it will be 1 only. You multiply 1 10 times, you get 1 only at the end. And it is even number on the top. So you end up with positive number. I already taught you why it is positive. Why can't it be a negative? Just a second. I'm trying to show you where it is. Hold on. Yes, here it is. Whenever the odd exponent for the negative number inside the bracket, then you end up with negative result. If the odd power comes, if the even power comes, you end up with positive result. So this is what we are going to do in this next exercise. So here, that's why I wrote positive 1, because even exponent. Here it's odd exponent, definitely negative value and 1. If it is odd exponent, negative result. Even exponent, positive result. So now what do we get here? Negative 1 whole raised to the power of 8. Again even. Even means positive 1. Here there is a difference again. There is no parenthesis. There is no bracket. Be careful. Now when there is no, what is the meaning of this one? Negative 1 whole raised to the power of 8. Negative 1 into negative 1 like this 8 times. Negative 1, negative 1, negative 1, 5, 6, 7, 8. And what is the meaning of this? Negative 1 time only. 1 is repeating 8 times. 1, 2, 3, 4, 3, 4, 5, 6, 7, 8. So this is the difference. Negative is only 1 time. So if you multiply 1 with 1, any number of times you get 1 only. And this negative, it is negative 1. And here we have negative into, now wait. Here, first of all, you have to solve this part, which is inside the bracket. Now, here, even power. So the result will be what? Even power means, even exponent is, the result will be positive. Positive 1, and we have one more negative here. So now negative into positive, that is negative 1. So I just want you to enter what's the answer for the sixth one. Just try solving number 6 and tell me what's the answer for that. You have 40 seconds of time. Okay, I can see negative 27. Let's see, negative 27 is right or wrong. So that's going to be negative 3. The meaning of this is negative 3, negative 3, negative 3. So 3 into 3 is 9. 9 into 3 is 27. Yes, I can see. I got the another value as well. So negative, 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 which is 3 times negative, negative. If odd exponent, we end up with negative. So the answer is negative 27. It's right. Yeah. So I think you people can able to handle these questions as well, and be careful with this. There is no bracket. So you did not apply this rule. the thing what we learned here, you can't apply this one when there is no bracket. When only there is a bracket, you can apply that. So here, I mean, sorry, what is the answer for this? You have negative and 3 power 3, that is directly 27. 3 into 3 into 3, that is 27. And number 8, it's going to be negative, square is there. It's going to be 36, positive 36, and positive into positive, which is negative 36. There is one negative outside, so that is as it is here. And then negative of power 2, even power, end up positive result. So I think you people can able to handle this 9th one as well. I'm skipping, and you can able to go with this one as well. 10th one, just simple. So 2 into 2 into 2 into 3 into 3 into negative 1 raised to the power of odd. So you end up negative 1. Negative result. 3 2s, that equals to 2 2 2, 8. 3 3, 9. Just multiply and negative 1. 9 8s or 8 9, 72. Negative 72 is the final answer. And what is the meaning of this 11th one? 1 by 4. What's the answer for 12th one? 1. Anything raised to the power of 0 is 1. And 3 raised to the power of negative 2, that is 1 by 3 square. And what is 14th one? 1 raised to the power of, I'll just do 15th one, you try 14th one. Now 15th one, 4 raised to the power of negative 2. Split that. Give it to the numerator and denominator. And what is the meaning of this? 1 by 4 square. The main division, 1 by 3 square. If it is a negative exponent, it will be like this. I already taught you. So now 1 by 4 square multiply by this part get reciprocated. 3 square by 9. 3 square by 1, sorry. This part will be like this. This part reciprocated. That's it. When we convert to division to multiplication. So that's 1 by 16 into 9 by 1. So that is 9 by 16 is the answer. So we are done with exercise 1. Without using calculator, we have to solve this and we are done. Just type exercise 2 so we can jump into exercise 2. If you are okay with exercise 1. Okay. Thank you. Thanks for that. Thanks for your reply. Okay, here what they are asking us to do, they're asking us to simplify so that your answer contains only positive exponents. The first one has been done for you. So you can see they simplified this. This is how they ended up with 8 by k square. So now question 2. So 3x square 2x cube. Just solving it, nothing else. 2 into 3, which is 6. X square into x cube. X square into x cube, that is x power 2 plus 3, which is x6 x raised to the power of 5. So that's what it is. Just need to multiply the coefficients and the base values along with the exponents. So 5 3 is 15. X power 4 minus 2. I just applying product rule for these. So x raised to the power of 4 minus 2, that is 15 x raised to the power 2. Same story here, multiplication is there, 7 into 3, and here there is a negative. Negative, this is main multiplication. It's not subtraction between those two. So negative 7 3 is 21, and m power 3, m power negative 3, m power 3 minus 3. Same basis, so you can apply product rule. That's what I'm doing. Negative 21, m raised to the power of 0. M raised to the power of 0 means anything raised to the power of 0 is 1. So negative 1. Negative 21 times 1, which is equals to negative 21. So I think you can able to solve this, which is 2x raised to the power of negative 6. Right? No. Be careful. This negative 3 is for this first one as well as second one. So that is 2 raised to the power of negative 3. X power 2 whole raised power negative 3. I'm splitting to the parts which are inside the bracket. Be careful. They are going to give options with just negative 6 here. That option will be, trapping option will be available in the exam, definitely. So be careful. You have to give it for inside both parts. So negative 2 raised to the power of negative 3, 1 by 2 by 3. And 2 into 3, x raised to the power of negative 6. So what do we get? 2 power 3 is 8. X raised to the power of, 1 second, raised to the power of negative 6 means what do we get? This is 1 by 8, 2 into 2 into 2. X power 1 by, this is x power 6, 1 by x power 6, that is 1 by 8 x power 6. Now, same story you have to do for everything. Just take the like terms and solve it. 3 into 3, 9. And there is only one negative, so keep it. A square, a power minus 5. A square minus 5. Apply the product rule, a power 2 minus y. B and this. B raised to the power of negative 3 and positive 8. Positive 8, negative 3. So now negative 9, a raised to the power of 2 minus 5, which is equals to negative 3, and b raised to the power of negative 3 positive 8, that equals to positive 5. So this is what we get. So finally we can write this as 9 negative 9 b raised to the power of 5 divided by a cube, because here we have negative, so that's going to be a cube. Same way we are going to simplify everything. Nothing else here. You just apply the seventh one. What do? 3x raised to the power of 4 and then x power negative 4, because here negative 2 positive 2. So that's going to be 3, just keep it side, and x power 4 and then x power negative 4. So base is same, so we can do what? Quotient rule. We are going to apply quotient rule. X raised to the power of 4 minus of minus 4. Whenever apply quotient rule, here it is minus. Whenever it is product rule, plus in the power. So this is going to be 3 x raised to the power of 4 plus 4, 8. Minus into minus plus, so 4 plus 4, 8. 3x raised to the power of 8. So same story. Apply the quotient rule, you'll get it. Try that. You can do this one as well. So this apply for this one, apply for this one, and this apply for this one, and apply for this one. Don't forget. You have to apply for everything which is inside the bracket and then solve it. You'll get it. I'll just solve. Let me solve this 11th one. So b negative 6, not negative, positive 6. Negative, negative, positive 2 into 3, 6. And then b 2 into 3, 6. So b same. Apply product rule. 6 plus 6, b power 12. So you can able to do these questions. You can just try them. This one as well you can able to do. Let me do this 14th one. K raised to the power of negative 2, which means 1 by k square divided by, this is the main division, x by 1 negative 3, 1 by k cube. So this, remove the division, the denominator part will become reciprocated, that is k cube by 1. 1 by k cube by 1, that equals to k cube by k square. So now k same, bases same, apply the quotient rule, that's 3 minus 2, that equals to 1. So now that is equals to, done, that is the value of k, that, the whole expression value. Let's solve this 15th one. So let's try to do x square, x power minus 3, and y cube, y power negative 4, z power 4, z power negative 5. So apply the quotient rule, 2 minus of minus 3, y power 3 minus of minus 4, z power 4 minus of minus 5. I just applied quotient rule, nothing else. 4 negative 5, 3 negative 4, 2 negative 3. So that is going to be 2 power, x power 2 plus 3 and y power 3 plus 4 and z power 4 plus 5. So that is going to be x power 5, y power 7, z power 9. So this is what we get after solving. Done. Whatever the questions I left, try yourself. Let me know if you can't able to do, or if you get a doubt. So let's get into exercise 3. So here in exercise 3, we have to simplify radicals. Just before I taught you how to simplify radicals. Yes, by using this short division method only, you have to simplify these radicals questions in exercise 3 now. So root 12, how do we do that? Root 12, if you do short division method, 12, 2, 6, 12, 2 threes, 3 ones, 2 into 2 into 3 you got. So 2 twos, this 2 twos you can take separate, 2 into 2 and root 3 separate. So root 2 square and root 3, square root of, so 2 root 3 is the answer. In the same way, you have to find for everything. I'll try for this 96. You try for 45, 18. Let me do for 96. 96 to start with least prime number. 248, 224, 212, 2 6, 2 threes, 3 ones. So it's going to be how many twos? 3 twos, 5 twos, and 1 3. 2 2 2 2 2 2 3. So every time you can't do this whole procedure. So for 2 twos, take 1 2 out. For another 2 twos, take 1 2 out. So the remaining thing which is inside the bracket only 1 2 1 3 is there, multiply them and keep it under the bracket. So this is going to be 4 root 6, 45 18 new people. How to solve this 75 thing? Just same thing, 75, 3, the 3 root 75. Just a second. I'm doing. Okay, I'm back. So how to do this? 3 root 75. I mean, sorry, not 3 root, that is 3 root 75. We have to solve only for this 75. So do we able to with 2, the least prime number? No, because 5 is there, it doesn't work in 2. So check with the 3, that is the next least. 3 works? Yes, it works. According to the divisibility test rule, 7 plus 5 is 12, which means 12 is going to work in 3. So I applied divisibility test rules to know that this is going to work in 3 or not. That's shortcut. If you don't know about divisibility test rules, just type it in the chat. I don't know. I'll just teach in a better way. Now 3, 2, 6, and then 3, 5 is 15. So 2, 3, 25 is 75, and 3 doesn't work. 2 plus 5, which is 7. It's not going to work in the 3. So I go with 5, next least. 5 5s and 5 1s. So here 3, it's not cubed root. Be careful. It is 3. 3 root 3 into 5 into 5. 5, 2 5s are there. So what we can do, 1 5 we can take out. 3 into 5 into root 3. That is 15 root 3 is the answer. And you try this one, try. We need to find the value of x here. Let's see, let me tell you how to solve this. 5 root 2, that equals to root x. So what is the value of x? Just a second. You see here, we have to solve for x. So how can we solve the value of x here? 5 root 2, that equals to root x. So we want only x. We don't want this thing with it. We want only x. So to remove this root, we do squaring on both sides. Square on both sides. Then the square root of, so 5, this 2 is exponent for 5 as well as 2. So this will become 25, and then square root 2 square, that equals to x. That equals to square root out 25 into 2, which is 50, that equals to x. Same way you have to do for the 8th one. Whole square, squaring on both sides, do it. Squaring on both sides, do it. Squaring on both sides, do it. Same story for 11th one as well. Let's do this 12th one. X root x. So what do we get? X root x. We want x value only. To get the value of x, we need to obviously square root on both sides. Here actually x is 1, x power 1 by 2. That equals to x power, that equals to root of 216. So what is this? X raised to the power of 3. If you add up 1 plus 1 by 2 that equals to root 216. So this is x power 3 by 2 that equals to root 216. I just added and made 1 power instead of 2x's. Now what do we need? We want only x. We don't want this exponent. We want to remove that exponent. How can we remove that exponent? In the power 3 by 2 is there. So we do 2 by 3 exponent 2 by 3 on both sides. So we do that. So what is this? X power 3 by 2 that equals to root 216. Same thing I wrote. But what I'm going to do here, I'm going to write both sides 2 by 3. So that this out, this out, you will end up with x. We are trying to eliminate. We are trying to reduce by bringing something in so that we can reduce. When you do it on both sides, that is completely fine. You're not doing something wrong. When you do something on both sides, like 1 plus let's say 1 plus 2, that is 3. When you do something, add 2 on both sides, it's still what? This is 1 plus 2 is 5. 3 plus 2 is 5. Value is not going to change whenever you add something on both sides. Whenever you do power 2 by 3 on both sides, the value on both sides is not going to change, just like this way. But when you do it 1 plus 2 equals to 3, when you do add 2 on both sides, add 2 on LHS, you get 5 3. No, this is not true. So whenever you do something on both sides, it's balanced. So I did that. Now I ended up with x square root of 216 whole raised to the power of 2 by 3. And I have to get rid of this thing. Now what can I do? The square and root. Let's see. I'm going to write this way. Root 216 whole square whole 1 by 3. I splitted this. Why? So that I can cross out this square and root. So now I ended up with x equals to 216 whole power 1 by 3. What is the meaning of whole power 1 by 3? The meaning of 1 by 3 is cubed root of 216. So now we are going to solve this cubed root of 216. So what is 216? 2, if you're good at squares and cubes, you'll be super fast. Like 2 2 is 4, 3 3 is 9, 4 4 16, 5 is 25. Like that, if you know, it is actually 6 into 6 into 6 will give you the result. If you don't know that, you have to do this factorization thing using short division method. 2 1s 0 and 8. If you didn't understood how I'm doing this, text me, I'll tell you in detail. 2 5 and then 4. So 2 2s and 7s. 2 doesn't work now. Go with the next least 3. 3 9s, 3 3s and 3 1s. So what is this here? X equals to cube root of how many 2s? 3 2s. And remember, 3 3s. Here the thing is cube. To reduce, you have to take 3 2s, 3 3s, not 2 2s, not 2 3s. Whenever it is 2 here, then 2 2s is right. So x equals to cube the root of this going to 2 cube multiply by 3 cube. So x equals to cube the root of 2 cube and multiply by cube root of 3 cube. So you can cross out this cube and cube root. Cube and cube root cross out. So you ended up with what? 2 and you ended up with 3. 2 into 3, that is 6. Done. We are done with 3 exercises from chapter 1. There are 2 more exercises.